Good day students, I'm Daniel Barnard. I'm the Fluid Lab Technician, and this is the lab for pumps in series and in parallel. Links to all documentation and data will be provided to you by the lecturer, and in this video series we'll have a look at the lab guide, the equipment we're going to use, and the procedure how to capture the data. Next video, let's have a look at your lab guide. Right, so here's lab guide for pumps in series and parallel, front page, there's the contents. Then point number one, the aim of the experiment is to determine the head versus flow curves for two pumps operating in series and then in parallel, and then compare them to published curves. Again, point number two, what you need to do, please have a read through that, and also, well, have a read through the whole document. Next point is theoretical background. And we continue with the theoretical background. There's an explanation of pumps in series and pumps in parallel. And then the next point is the apparatus we'll be using. There again is the picture of the pump station we're going to use. And this one is the control panel for the pump station with all the labels showing which screen is what data. Then we have two experimental procedures. The first one being for pumps connected in series, and then for pumps connected in parallel. Then results, have a good read through that. Obviously you have to plot the head versus flow experimental for pumps in series and in parallel, and then compare them to the theoretical pump curves. Also note that the theoretical pump curves will be at a speed of 2900, and our experimental curves will be at a speed of 2500. So therefore you need to use affinity laws to compare the two. Here's the theoretical pump curves, and there you can see it's for a speed at 2900 RPM. Alright, next is what the data is going to look like. First sample is a series, so you will have data for pump number 1 and for pump number 2, and similarly you will have data for pumps when it's connected in parallel, again for pump 1 and for pump number 2. Here at the bottom is a description of what data you will receive and which data you need to calculate, and there's some constants that you need to consider to do the calculations. Next video, let's have a look at the equipment. The pump station we'll be using. So we have two pumps on the left and then the control panel for the two pumps. Let's start on this side. We have two pumps, pump number 1, pump number 2. Here at the back we have sensors. This is torque sensors. Then obviously the electrical motors that drives the pump. We're going to measure the electrical inlet power, and then over here on the shafts, the speed, the RPM of the shaft is measured. And again, pump 1, pump 2, and these big lines, this is the suction lines, the inlet lines, and then these over here is the delivery lines. This little red sensors is pressure transducers. Here's the inlet pressure for pump number 2, there's the inlet pressure for pump number 1, and this is the outlet pressure for pump number 2, outlet pressure for pump number 1. And then if we follow these lines, they join into one, they come down all around through here. This is a control valve, so I can control the flow of the pumps, and this is a electromagnetic flow meter, and then the water is delivered back into the reservoir. These blue valves over here, we're going to make use of them to connect the pumps in series and parallel. If we want only one pump to run, we make sure we isolate pump number 2 and also the interconnecting line, and then we have to make sure that pump number 1 is open. Then when I switch pump 1 on, the water will be sucked through pump 1 and deliver it, and it can't interfere or go into pump number 2. If you want to connect it in series, which means pump number 1 needs to deliver water to pump number 2, we open the interconnecting line so it will deliver water to pump number 2, and then we also have to make sure pump number 2 is open, and close the delivery line for pump number 1. Now the water will be pumped from pump number 1 to pump number 2 and back to the reservoir. If we want to make a parallel connection, we want to close the interconnecting line and make sure pump number 1 is open and pump number 2 is open. In this case, both pumps will suck water from the reservoir and both will deliver into the same delivery line. So that's in parallel connection, and the previous one series. Then the control panel. The top numbers is for pump number 1 and the bottom numbers is for pump number 2, and this one sitting here by its own is the flow meter, because we only have one. Then this is the inlet pressure, that's the outlet pressure, that's the pump speed, this is the torque, and this one is the electrical power in. Also we'll have here is the on-off buttons for pump number 1 and pump number 2, and this is a variable speed drive, so we can adjust the pump speed for both pumps. The procedure to capture data for pumps in series, we have to make sure that pump 1 provides water to pump number 2, so we need to open the interconnecting line, and we're going to close off the delivery of pump number 1. So pump 1 will deliver water to pump 2, and we make sure that pump 2 delivery valve is open. We also make sure that the control valve is fully open before we start the pumps. We start both pumps, and again we're going to make sure that the speed is going to be 2,500 for each of them. This speed drive is very sensitive, so it's not always possible to get it exactly on 2,500, but that is definitely close enough. Now we can see the maximum flow through the pumps connected in series, setting about 15 cubes per hour. And again, with the control valve fully open, this will be our first data point. And again, we capture the inlet pressure, the outlet pressure, the pump speed, the torque of the pumps, the electrical power in, and the flow. For our next data point, we're going to close the control valve slightly. And we're going to wait for our flow to settle. And that looks stable enough. So that will be our next data point. Then for our third data point, we're going to close it again slightly. And you can hear the pumps making a noise. And we adjust the speed again, closer to 2,500. We wait for the flow to settle, and that will be our next data point. So we continue this procedure until our flow value, our last reading, should the flow be between 0 and 1. And that will be all your data required for pumps connected in series. For our pumps in parallel, we need to connect our pumps in parallel, of course, which means both pump 1 and pump 2 must deliver to the same delivery line. So we want to close the interconnection line, so pump 1 can't deliver water to pump 2 anymore. And we want to open the delivery for pump number 1 and open the delivery for pump number 2. In this case, both pumps suck water from the reservoir and they both deliver to the delivery line. And then again, to start, we want to make sure our control valve is fully open. Then we're going to switch on both pumps. And we're going to adjust their speeds to 2500. Again, this speed drive is very sensitive, so we try to get it as close as possible to 2500. That's close enough. And if we look at the flow value here, this is our maximum flow with our control valve fully open. So that will be our first data point, and we capture the inlet pressure, the outlet pressure, the speed, the torque, and the inlet power, and of course the flow value. For our next data point, we're going to close the control valve slightly. We're going to wait for our flow to settle. The flow is stable, so that will be our next data point. For our third data point, we're going to close it again slightly. We're going to wait for our flow to settle. Alright, flow is stable, and that will be our next data point. And this procedure is continued until our flow value is between 0 and 1. Our last reading the flow will be between 0 and 1. The raw data for pumps connected in series and connected in parallel will be provided to the student. It's up to the student to do the calculations for the rest of the data that's required to finish this lab, and also take note of the constants that is mentioned in your lab guide, which will enable you to do all the calculations. Also note again that the theoretical pump curves, as done at a speed of 2900 RPMs, and the experimental data is captured at a pump speed of 2500 RPMs. So it's necessary to use the affinity laws to convert either theoretical or the experimental to the same speed, and able to compare the graphs.